A farmer has 500 acres of arable land on which he wants to plant potatoes and corn. The farmer has $40,000 available for planting and $30,000 for fertilizer. Planting 1 acre of potatoes costs $90, and planting 1 acre of corn costs $50. Fertilizer costs $30 for 1 acre of potatoes and $80 for 1 acre of corn. Part A. Find a system of inequalities that describe the number of acres of each crop that the farmer can plant with the available resources. Graph the feasible region. The question is asking us to specifically find the inequality to describe the number of acre of each crop. Because of that, we recognize that there are two types of crops. One is potato and another one is corn. And so we will let x be the number of acres of potato crops. And so X represent the number of acres, not the potato, but the number of acres of potatoes specifically. Then Y be the number of acres of corn crop. Now, the available resource is that the farmer has only $40,000 for planting, and 1 acre of potato costs $90. If we plant 2 acres of potatoes, then we will take 2 times 90. If we plant 3 acres of potato, then the cost would be 3 times 90. And therefore, if we plant X acres of potatoes, then the cost would be 90 times X, or X times 90. Similarly, if we plant 1 acre of corn, then the cost is $50. If we plant 2 acres of corn, the cost would be 50 times 2. If we plant 3 acres of corn, then the cost would be 50 times 3. If we plant Y acres of corn, then the cost would be 50Y. Now, this is the cost of planting potatoes and corn, and the resource for planting alone has to be less than or equal to 40,000 because the farmer only has 40,000 available for planting. Similarly, for fertilizers, 30x would be the cost for fertilizer for potatoes, and therefore 80y would be the fertilizer cost for corn. And the sum or the total of the fertilizer cost has to be less than or equals 30,000. And so we have a system of equation. Because of these large number, we can divide by 10 from each side of the inequality to get a smaller inequality, which is 9x plus 5y less than or equal to 4,000, where we divide by 10. Similarly, 3x plus 8y less than or equal to 3,000. Then we solve this system of inequality by graphing the two inequalities and shade the feasible region. There is no negative x or negative y in this case, so we will simply focus on the first quadrant. The reason is that we cannot have negative number of acres of potato, so x has to be 0 or more, y has to be 0 or more. This means we are in the first quadrant. To graph this inequality, we pretend that we would graph the equation first. And we see that the y-intercept for the first equation is 800 because when x equals 0, y equals 4,000 divided by 5, which is again 800. The x-intercept is when y equals 0. And if we take 4,000 divided by 9, we will get 444.44. And so we have 2 points. With these 2 points, we draw the solid line because the equal sign is in the inequality. Connecting the 2 points with a straight line because this is again a linear equation. We use a solid line here because of the equal sign, inequality. To determine the shaded region, we pick any point that is not on the line. A convenient point to test is the origin 0, 0. If we pick the point 0, 0 and plugged it in to the first inequality, we see that 0 plus 0 is less than 4,000, and so we will shade everything on the left hand side or below the line because 0 is on the left part of the line. The origin is on the left part of the line. But remember that we cannot shade the negative x or negative y because there is no negative acre of potato or negative acre of corn. And that is the solution for the first inequality only. For the second inequality, we would draw a straight line again. This time, when x equals 0, y is 3,000 divided by 8, which is 375. So the y-intercept is 375 when x equals 0. And when y equals 0, we would have x equals 3,000 divided by 3, which is 1,000. And so the x-intercept is 1,000, not drawn to scale. And we would connect the 2 points to obtain a straight line. And again, this is the solid line because of the equal sign in the inequality. To determine the region where we would shade it, we would plug in the point that is not on the line, any point that is on the line. 0 plus 0 is less than 3,000, so we will shade the part that is below the line where 0 or the origin is included. The solution of the system of equation is the part that we shaded twice, and this is called the feasible region or the solution region. Can the farmer plant 300 acres of potatoes and 180 acres of corn? First, since we let x be the number of acres of potato, we have x equals 300, and similarly y equals 180. The question is simply asking if the point 300, 180 is in the feasible region, in both regions that we shaded twice. And when x equals 300, y equals 180, we see that that point is indeed in the region that we counted twice. So the answer is yes. Similarly, for part C, x equals 150, y equals 325. And so the question is the point 150, 325 in the feasible region. And we see that that point is outside of the feasible region. And so the answer is no. And so yes for part B and no for part C. It is difficult to determine the location of these points in the coordinate axis here. One thing we might want to do is to plug in the point. For example, for x equals 300 and y equals 180 for part B, we plug in these x and y to check the inequalities in the system. 90 times x, but x is 300, plus 50 times y, but y is 180. And we see that this is 36,000, so that is well less than 40,000, so that checked. We still need to check the second inequality. 30 times x, x is 300, plus 80 times y, y is 180. And this is 23,400, and this is well less than 30,000. So this checks out as well. Since the points satisfy both inequalities in the system, not just the first one but the second one, we say that this ordered pair is in the feasible region. And if we were to check part C, we will see that one of the inequality will not be satisfied, and therefore it is not inside the feasible region.